Okay, so let's take one closer look at the square root property. We know factoring very well. The square root property was sort of introduced to us in chapter 10, and I shared with you how it's a method to actually solve quadratics. So let's take a closer look at that because it's important for the build-up for completing the square. Okay, so let's make sure we totally understand it. So again, the square root property says that if I have something like x squared equals a, then what I can do mathematically is apply a square root to both sides to clear that square. Now, of course, when I do that, because we know that every number has two square roots, a positive and a negative square root, right? When I introduce that square root, I've introduced a plus minus to the answer. So over here, the radical clears out, and we're left with x equals plus or minus whatever the square root of a is. So that's what your square root property is. It's essentially saying, again, if you apply a square root, you've applied a plus minus to the situation. So, oops, this isn't even an equation. So solving x squared plus 25 equals 0. My first move would probably be to subtract 25, and that gives us x squared equals negative 25. So I have a classic situation for my square root property. If I take a square root of both sides, I've introduced a plus minus. The radical clears out over here, and then the square root of 25, negative 25, is 5i. So there's two answers here, right? There's two complex answers to this equation, x plus 5i and 5i and negative 5i. Okay, and then a scientist or an engineer, right? We're talking about a system that's in a really nice cycle motion. It's constantly going up and down, up and down, up and down, all right? Or it's constantly going in a circle. So this is a nice, unique situation with regard. We call it simple harmonic motion, but I'm getting into trig. All right, so back to college algebra, or intermediate algebra. Again, a little bit more going on here. There's a lot of ways we can approach this, but what I'm going to do is take advantage of the fact that I do have something squared, and so that gives me the opportunity to use the square root property. But I need to get that piece that's squared off by itself. So we'll employ some algebra. I'll subtract 45 from both sides, and that would give us 5x minus 1 squared equals 45. The next move I would do is divide by 5, and that leaves us with x minus squared equals 9. And so that's good news for us because now I have the situation that requires the square root property. I have something squared equals 9. So applying the square root property and introducing my plus minus, we end up with x minus 1 equals plus or minus 3. And so again, there's two equations here. There's x minus 1 equals positive 3. There's x minus 1 equals negative 3. And so in both cases, if we solve them, we end up with x equals 4 for one of them, and x equals negative 2 for the other. All right, and again, we can go back and check those and see that they actually work, which they do, and we'd be good to go. All right, so there's our square root property in a tougher case. Letter C, this last one, you could solve this by subtracting 49 from both sides and then factoring the trinomial. However, if you look real closely, what I have there is what we identified earlier in our semester as a perfect square trinomial. It turns out that this is 4x plus 3 times 4x plus 3, which is just saying, oops, I should say 2x plus 3 squared. Okay, and so now I can employ the square root property. So it turns out for that case, it's probably a lot faster than factoring if you see that. And so what we have then, if I take a square root, introduce my plus minus, we get 2x plus 3, and that's plus or minus, I think that would end up being 7. All right, and again, we have two equations here. We have 2x plus 3 equals 7, or we have 2x plus 3 equals negative 7. So we'd have two little equations to solve. So subtracting 3, dividing by 2, there's one of our solutions. So x equals to 2. And then over here, if we subtract 3 and divide by 2, we get x equals negative 5. as one of our solutions. And again, you could check them. They do in fact work. All right, and that would be our thing. So the idea then is so there's the square root property. So we now know for sure two ways to solve a quadratic, right? Factoring or the square root property. All right, and we're going to introduce ourselves to completing the square next, but it turns out that to complete the square, we're actually trying to invoke the square root property. And so that's going to require some steps to occur, some methods of thought, but it turns out that the completing the square process is actually built to create the situation like this, where I can, or like this, or like this, where I can actually use the square root property to solve. Alright, so obviously more on that on the next video.